Today, we are going to see a topic on megawatt mile method in restructured power system. In restructured power system, many transactions occur. Say, for example, Gencos inject the power at different buses, and distribution companies also withdraws the power at the different location. Multiple users shares the same transmission network. Okay, so a fair transmission pricing method should reflect the actual network usage, and also it considers the distance and as well as the power magnitude, and also it avoids a unfair cross subsidy. Okay, so unfair cross subsidy also it should avoid. So the megawatt mile method was developed to overcome the limitations of this postage stamp and contract path method. Okay, so what are the limitations in the postage stamp method and the contract stamp method that is overcome by this megawatt mile method? What is this megawatt mile method? Megawatt mile method allocates the transmission cost based on power, that means power in megawatt, into distance in miles. So, megawatt mile method is a transmission cost allocation technique that charges users based on the magnitude of the power flow and the distance traveled on each transmission line determined through the power flow analysis. So the more power you transmit, the farther it travels and the more you have to pay. So in the megawatt method, so more power you can transmit, and it will transmit, they will transmit your power to that particular place, but you need to pay the, okay, so if the distance increases automatically, you need to pay. So, what is the core concept in this megawatt mile method is electricity does not follow the contracts. It follows the low resistance path. So, the power flows through multiple transmission lines. But a megawatt mile method uses the power flow analysis. Okay, power flow analysis, and it measures how much transaction, um, how much each transaction load at each transmission line. Okay, so that one it will calculate and charges users according. So how this megawatt mile method works step by step. First, how to calculate the transactions. For example, generator at bus A and load as bus D. The transaction size take for example as a 100 megawatt. Now you need to perform the load flow study. Usually DC load flow study is used. Okay, DC load flow study is used uh, to determine change in the power flow. That is delta. We are taken as delta megawatt on the each line, and due to the specific transaction. Okay, now we are computing the megawatt mile for each line. For each transmission line I, megawatt miles of I is equal to change in the megawatt into line length. So this is how we are calculating the megawatt miles. Okay, megawatt miles of each transmission line. So megawatt miles of I is equal to change in megawatt of I into line length of I. That is transmission line. The fourth step, calculate the total megawatt miles. How to calculate this total megawatt miles in the sense summation I is I change in the megawatt of I into L. So for all this total I, so I is equal to 1, 2, some 5 or 6, like that, total megawatt miles we are calculating. Okay, so now we are calculating the transmission charge. So transmission charge is equal to this total megawatt miles into dollars per megawatt. Okay, total megawatt mile into dollars per megawatt. So for each megawatt per mile, you need to pay for that particular into that total megawatt. So simple numerical example we can solve such that you can understand this megawatt mile method easily. Say for example, transaction we are going for 100 megawatt. In the line 1, 60 megawatt it is we are going to transmit for 50 miles. Line 2, 40 megawatt we are going to transmit for 30 miles. The cost per rate is the $10 per megawatt mile. So, for example, line 1, 60 into that particular distance. Okay, 60 into 50 is 60 into 50 is 3000. Okay, 3000 megawatt miles. And line 2, 40 into 30. 40 into 30 is for 1200 megawatt miles. So the total megawatt miles is what? 4200 megawatt miles. Okay, now we are calculating the transmission charge. Transmission charge for 4200 megawatt miles into dollars per megawatt mile. So dollars per megawatt mile is what? Into $10. So into $10 is $42,000. So longer the distance and higher the uses, next higher the charge. Okay. So in this we come to know that long distance and a higher usage, higher charge. Short distance, shorter usage, shorter the charge. Okay. But usually transmission will be in the longer distance and higher usage. So this is one of the limitations in the megawatt mile method. Okay. So even though limitation is there, so it is follows the power flow analysis. That is one thing. So whatever the longer the distance, if you go for long distance, then you need to pay more. And megawatt sending is more, you need to pay more. If you go for very shorter distance and the megawatt generator also very less, then you need to pay less. In that way, this megawatt mile we are calculating. This is a small example such that you can easily understand. Now coming to the block diagram of this megawatt mile method. So first, from the generator company, the power is being injected, and we are following this power flow analysis. Majorly, we are following the DC load flow analysis, and power flow megawatt. Okay, line by line power that we are calculating, and we are calculating the megawatt into length of the line. Okay, that is megawatt mile calculation. After that, we are calculating the transmission cost. That is this megawatt mile into dollars per megawatt mile. Okay, that one we are calculating. This is the simple block diagram of the megawatt mile method. So what are the key features of this megawatt mile in the sense distance sensitive? Okay, if the distance increases, then cost also increases. Usage based. It is based on usage based. Line by line costing will be there. Flow based pricing will be there because we are calculating the power flow analysis also. So the flow based pricing will be there. More accurate than the postage stamp and contract path method. Compared to this postage stamp and the contract path method, this megawatt mile method has little bit advantages. What are the variants in the megawatt mile method? So first variant is absolute megawatt mile method. So absolute megawatt mile method is a flow-based transmission pricing technique in which transmission cost is allocated based on the change in the megawatt modulus of absolute value of the we are making this absolute value change in the megawatt we are making it absolute into line. Okay, so that we can tell it as modulus also or absolute value. So any minus negative value also we can make it to absolute value. So absolute value either it may goes to negative also, you need to pay. Either if goes to change that also you need to pay like that. So absolute value of the power flow change is used. So direction of the power flow is ignored here. In the absolute megawatt method, direction of the power flow will be ignored. So any line usage, whether the positive or negative, because we are performing the DC load flow analysis, no? So positive or negative contributes to the transmission cost. Okay. Next, why absolute megawatt mile? So in real time system, power may create counter flows. Say for example, it will flow in the opposite way of excessive power. So it will reach at the load and again it will return flows. So counter flows, that is the negative flow. So using the signed megawatt values may cancel the cost unfairly. Okay, so taking absolute values ensures that every users pay for the actual network usage, no free riding due to the flow direction. So that's why we are going for absolute megawatt mile method. So what is the basic principle in this? The power flow causes stress on the transmission. So stress occurs regardless of the direction also, because direction we are not taking the absolute. No? So absolute megawatt captures total line usage, avoids the cancellations due to the counter flows. Now, second one is signed megawatt mile method. So, in this signed megawatt mile method, is a improved version of the megawatt mile method pricing technique in the deregulated power system. Unlike this absolute megawatt method, this approach retains the sign, that is plus minus. There, we are taking the absolute values, modulus values. So here it is taking the sign plus value minus value of the power flow changes caused by the transaction, allowing credits for counter flows that release congestion. Okay, so sign, it retains the sign of the power flow changes and also allowing the credits for counter flows that relieves the congestion. So counter flows also it is uh, allowed. Okay, so it is more economical, meaningful, and fair because it recognizes that whether a transaction uses or supports the transmission network. So power transaction changes the power flow on the transmission lines. The changes may be, say, for example, if it is positive, means increase in the loading. That means in the network usage. If it is negative, means reduce the loading. That is a network relief. Okay, so the signed megawatt mile method charges or credits users according. Okay, so based on this, say for example, positive means increase in loading, so network usage will be there. Negative means reduces network usage, network relief will be there. Okay, so usage means positive, not use means negative, like that. Okay, so in the signed megawatt method charges or credits users according. So, megawatt mile calculation with the sign. For each transmission line, signed megawatt mile of I transmission line is equal to del megawatt of I into line length of I. So, which reflects the direction of the flow and can underestimate the cost. Okay, so underestimate the cost. That is also one limitation is there. Okay, but it reflects the direction of the flow. Because of the sign, we can easily tell the direction of the flow. Next comes the modified megawatt mile method. So in this modified megawatt mile method is an enhancement of the basic megawatt mile method and side megawatt mile methods used for fair transmission cost allocation in the restructured power system. In the modified megawatt mile calculation, the modified megawatt mile of I is equal to del P of I, that is this change in the megawatt into Li, length of the line, into WA. WA is the weightening factor or modification factor. Okay, so del PA is nothing but the change in the megawatt of I into Li is nothing but length of the I, and WA is the modification factor of the weight. So here weightening factor also we are add. Okay, compared to and here also we are taking the modulus. Okay, modulus means absolute values we are taking. Okay, so it improves the fairness by considering the actual power flow, includes the transmission line losses, and accounting for line loading and congestion also, and avoids unrealistic negative charges. So this technique includes the transmission losses, power factor, and voltage support. So which ensures the fairer and more realistic method. So what method? This is modified megawatt mile method. So modified megawatt mile method we can use in few places, depends on your situation. Next, what are the advantages of this megawatt mile method? Main advantage of this megawatt mile method, which reflects the actual network usage, considers the distance traveled also. It also fair cost allocations will be there, which encourages the efficient generation placement, and also suitable for wheeling charges also. Wheeling transmission cost also suitable for wheeling transactions also. So these are the advantages of this megawatt mile method. What are the limitations and challenges of this megawatt mile method? So it requires detailed power flow studies. Okay, computationally complex. Complexity will be there. Basic version ignores the losses. So, but we need to include the losses also. But if you include the losses, the complexity of the system becomes little bit. That means software becomes little bit complex, and difficulty with the parallel and loop flows, and data is intensive. Okay, the key point in this megawatt mile method improves the fairness but increases the complexity also. Whereas our previous two method, no complexity, but there more limitations are there. If you want more fairness, then complexity also increases. The comparison of this megawatt mile method with the other methods. So, if you take the postage stamp method, contract path method, megawatt mile method, locational marginal pricing. So, based on the distance based, flow based, and complexity. So, postage stamp method. So, distance based, no distance based, flow based also no. Complexity is little bit. Contract path method, distance based, some partial is there, and no flow based, and complexities 2 stars, little bit complex is there compared to postage stamp. Next, if you take a megawatt mile method, distance based also there, flow based also there, and complexities little bit it is there. Okay, but locational marginal pricing, same, distance based is there, flow based is there, but complexity is somewhat more because your location also adding, similar to megawatt mile, but based on the location. So software becomes little bit complex in scheduling the things. Here losses, if you take losses, then complexity again increases. Okay, so what are the applications of this megawatt mile method in the restructured power system? So mainly it is used for wheeling charges, inter-regional transactions, cost recovery of the transmission assets. So often used as a bridge method before adapting the locational marginal price. Okay, because wheeling charges means transmission wheeling charges, inter-regional transactions, next to cost recovery of the transmission assets and all, we can go for this megawatt mile method. But it is a bridge method, often used as bridge method before adapting locational margin pricing method. You can adapt this megawatt mile method, and you can just get the idea. Okay, to get the idea you can implement this, and how, what are the things we are changing in the locations, how, because it is not based on the location, no, just a megawatt mile method, instead of even states, intra-states, okay, so interstates, whatever it might be, it depends on the distance and everything, it is calculated. Okay, it's not based on the location marginal pricing. Okay, so these are the applications of this megawatt mile method.